Day 3 of virtual learning. Here's the warm-up. Scroll down to number 4 so you can see it. When you're ready, here we go. Number 1, in the classroom, the ratio of boys to girls is 3 to 4, so I made my ticket. 3 boys, 4 girls. Which of the following could represent the total number of students in the class? Well, this problem is slightly different than the earlier ones from this week, because if we had 3 boys and 4 girls, that's a total of 7 students. So that means the students in the class must be a multiple of 7. It could be 7, 14, 21, 28, 35. We are talking about multiples of 7. Number 2, Adrian has at most $25 to spend on school supplies. That means he can spend at most $25. So could he spend $25? Yes, $25 is included in the solution set, but he also could spend $10 or $0 or $5. Any amount that is 25 or less is what Adrian spent. Number 3, which of the following has the greatest value? Again, we'd put these in our calculator and see that negative 11 minus a negative 15 is 26, which is the greatest value of the answer choices. Number 4, when we look at this trapezoid, there is no formula that we know that can find the area of this, so we have to split it up. The rectangle's area is length times width, 15 times 6, which gives us an area of 60. The triangle is 1/2 times base times height, which means 1/2 times 3 times 6. Now, while the height isn't given to us, we know this is a rectangle. So if this side of the rectangle measures 6, that means this must also be 6. And 1/2 times 3 times 6 is 9. 90 plus 99 gives a total area of 99 square inches. The integer daily dose for today is a chart with some cities in Alaska, and it looks like one in Buffalo with some temperatures. Go ahead and pause the tape now and work through the questions. Okay, number 1 says, which city has a temperature that is the coldest? The coldest is the furthest to the left, or if we were thinking about a thermometer that was vertical, we would think about the number that is the lowest down. In this case, negative 9 is the lowest number, which means Anchorage has the coldest temperature. The warmest temperature is the exact opposite. Which one would be the highest on the thermometer or the furthest to the right, which would be Buffalo? And which city has a temperature between Anchorage and Fargo? Well, Anchorage is negative 9. Fargo is negative 5. So we would have to have something in between negative 9 and negative 5, which would have to be Nome at negative 6. Okay, we are still looking at the same question for the week, is how can the median, mean, and range be determined from a data set? There's a link for the activator. You may have to type it in your browser, or if you have the PDF open, you can go ahead and copy and paste that now. Today we'll be looking at the median. The median is the exact middle number of a data set. This should be in your notes. To find the median of any data set, a couple things. First, the numbers must be listed from least to greatest. So when you get a data set, the first thing you must do is put those numbers in order from least to greatest. You see it's in all caps. That is important, and we will see why here. So if we were to determine the median amount of magazines sold over the 5 weeks, we see 5 weeks with the number of magazines sold each week. So if we want the middle number, if we just looked at this, it's tempting to say the median is 175 without having to do any work because it looks like it's in the middle. But we have to put these numbers in order from least to greatest first. So go ahead and pause the tape and do that now. Okay, so there are the numbers in order from least to greatest. Now, to find the middle number, here's the strategy. We are basically squeezing everything towards the middle, which means we are going to cross out our greatest value and our least value. We'll cross out our greatest value and our least value, and we are left with one number in the middle, which is 175. So 175, in this case, does represent the median number of magazines sold. Okay, here are 2 additional sets. We're going to take a look at these together. The first step is to put each data set in order from least to greatest. So pause the tape and do that now. All right, so in blue, you see the first data set in order from least to greatest. So looking at this data set, The easiest mistake is people think that 12 is the median number because it looks like it's in the middle of these numbers. But when you actually put them in order, you see 12 is definitely not the middle number. It's actually the largest number. So to find the middle number, I take out the largest and smallest values. I take out the largest and smallest values, and I see that in this data set, the middle number is actually -1. You can't fall into the trap of looking and just thinking what the middle number might be. You would run into the same situation here. If you just looked at this data set, you would think that 42 would be the middle number if you did not put them in order. But again, in this case, it happens that 42 is actually the largest number. So to find the middle number, well, first I want to double check. There's 1, 2, 3, 4, 5, 6, 7 numbers in my data set. And I recorded 1, 2, 3, 4, 5, 6, 7 numbers. So I'm good there. I also made sure that because 17 was recorded in this data set twice, I also recorded it twice. Now to find the middle number, I am pressing everything towards the middle. So I am going to get rid of the largest and smallest number. It always goes in pairs. The largest and smallest number. The largest and smallest number. And I see that the median of this data set is 29. Okay, similar to how we did with mean, we are going to use the same strategy to find the median from this chart. A common mistake that students make here is they start crossing out these bottom numbers, like they get rid of 86 and 80 and 81 and 85 and 82 and 84 and see that 83 is the median. But that's not true because these numbers are just keeping track of the heights of the students that are actually in the class. So to find the median from a dot plot like this, it's the same idea. We're going to get rid of one of the smallest scores and the largest score. Then we're going to get rid of the next smallest score and the next largest score. And we're going to keep working in pairs and push towards the middle. So we'll get rid of a smallest and a largest, a smallest and a largest, a smallest and a largest. And we'll see that everything remaining is right here, which means the middle number must be 84. Okay, before you get to the bit.ly, here is a student was scoring a set of algebra quizzes, and there are the scores. There's quite a few of them. So your job is to answer the 3 questions. The third one is a little bit tricky. We'll go over it, and then you can try the work. Pause the tape now. Okay, so in black, you'll see that I put the numbers in order from least to greatest. The way that I did this on my piece of paper is I copied the original data set down, then as I ordered them, I crossed them out, so I knew I was going to hit each number. So I got rid of the 55 when I wrote it, then the 56, then the 79, then the 79, then the 80, the 80, the 83, the 90, and the 94. That way I ensured that I had all of my numbers listed. Now to find the median, we're squeezing towards the middle, so we get rid of our highest and lowest scores. Again, it always goes in pairs. Our highest and lowest scores. Our highest and lowest scores. Our highest and lowest scores. And we see that the median score was an 80. Now the unique thing about a median is it literally divides the numbers exactly in half. So we had 4 scores that were higher than the median and 4 scores that were lower than the median. Number 3, that last question there is a little bit trickier and just requires you to read. It says, if the teacher threw out the lowest 2 scores, what would the new median be? So if the teacher threw out the lowest 2 scores, that means that this 55 and this 56 would not count. So if the teacher had to recalculate the median, it would just be from these 7 scores, and then we'd follow that process. Largest and smallest, largest and smallest, largest and smallest, leaving you with a median of 80. Okay, here's a work for today. It's bit.ly/median, part 1.